Hello guys, in today's video we'll be solving the question 116, lead code 116, which is populating next right pointer in each node. Now first I thought that it is a very boring question and it is kind of easy, but there is a tricky part. There is, and it is a very interesting problem, to be honest. I'll just explain you the problem. Okay, wait, yeah. So basically the problem says that you are given a perfectly complete binary tree. Now, what do you mean by perfect complete binary tree? Basically mean that all the nodes, that at every level, the nodes are in the power of 2. Basically, in the level 1, the nodes are 2 to the power 0, then 2 to the power 1, then 2 to the power 2. Okay, or you can also say like if you sketch a line, if a horizontal line you sketch, then in the level 1 it's 1, then in level 2 it's 2, uh, then in level 2, level 0, level 1, then in level 2 you have 2 to the power 2. Okay, getting what I'm saying? That every node has child. Basically every parent has child. Now for example, if we have to create, like we have to go down to the tree, we have to create more, then what we'll do, this guy will have two child, this guy will have two child, this guy will have two child, and this guy will have two child, to make it perfectly complete. And now what the question is saying, so the question basically says that wait, you are also given a next pointer here. Now what's the catch? The catch is the next pointer. Now you are given the next pointer. What do you mean? Basically you are given a next pointer, treat it like this. This is the next pointer, which is pointing towards the horizontal, which is pointing towards the horizontal, or basically this guy is pointing towards null because it does not have any node here. But this guy, okay, this guy is pointing towards the right of this node. Okay, now the problem is in this guy. Now these two nodes are different, and this is the main catch of this question. Now I'll just code it out and explain it to you more clearly. Basically we have to connect all the nodes in all the level in this with a next pointer. Okay, of course, I mean there are two ways of doing it. We can also use DFS for it, which is by using queues, but I think I prefer DFS more because I think DFS is more easy. So we'll start solving by DFS. Okay, first we'll say if base condition, if there is no node, or if not dot left, you don't have the left guy, basically the left child, then just return. Okay, now if you have node dot if you have node dot left, then basically if you have the left guy, then make it point towards the right guy. Basically if you have this node, then make it point to the right guy. Even though if you don't have, of course it's a perfectly complete binary tree, so you will definitely have this guy too. So just make the next pointer point towards it. And how will we do it? We'll do it by, there is no need of putting exclamation because it is already there, because it's a perfectly complete binary tree. Now node dot left dot next equals to node dot right. Okay, now we have connected on the first level. Basically we have made these connections are done. Okay, now the main story is on the last level. If node dot next exists, then what we're gonna do is node dot right next guy point towards node next, and node next make it a connection with the left part. Yeah, I'll just explain this thing, like what is this thing, what's happening here is, yeah. Now why did I write this? The point of using this, what this code actually does is, for example, we are on this node, we are here. Okay, now basically it says if node dot next. So node dot next basically means if it is here and you check if there is the next guy, if there is the next guy, then we also want a connection between these guys, but these guys are from different parents. Okay, so we make a connection here if node dot next. Okay, if this exists, then what we're gonna do, and this connection is already made in the previous step. Okay, so if there is a connection, what we're gonna do is we're gonna take the this node's right part, make a connection, basically the next with whom the nodes next, and of this node's next left part, basically we go next and this node's left. Okay, I hope I'm very clear. I think you should try this question once, at least try it twice or thrice to get in, to really absorb this question. And I think it's a very interesting question. Now we'll just make the DFS call. We'll call DFS. First we'll go to the left, then we'll go to the right. Now we'll call DFS root and return root. Okay, let's see if this works. On the left, and yeah. So I hope guys I'm very clear, and I hope you understood the question. You should try it once, and of course there is another way of doing it by implementing by using DFS. But this thing I think it is more easy to understand. That is very complex, but you can try it for your practice. And if you have any doubts, please type it in the comment section. Thank you so much.